Hello everyone. In this part I want to introduce the notion of double integral. But first I want to mention about the function of two variables. As you remember, we have one input and one output for the function of one variable. That is, we have x as an input and y as an output for the function of one variable. Y is equal to f of x. For the function of two variables, we have two inputs, x and y, and we still have one output, that is z. In this case, we write z is equal to f of x, y. So, for each values of x and y, we have a number z. This is the idea of function of two variables. Using the same idea, you may define the function of 3, 4, and 5 variables also. As I told you, for each points of x and y, you have a number z. Combining all these values z, you have this blue surface. The definite integral can be extended to functions of more than one variable. Now consider the function of two variables f of x, y. The double integral of f of x, y is denoted by this notation. Okay? Here R is the region of integration in the xy coordinate. Now let's remember the idea of integral for the function of one variable. What we had before, we had a function of one variable. Let's say y is equal to f of x, and let's say it is the graph of f of x. Okay. Let's say the domain of the graph is from A to B, and we want to compute the area under this curve f of x. What we did before, we chose, let me pick a color, we chose a length. Let's call this length as dx, and we created a rectangle. Okay, we created a rectangle. We created a rectangle, and let me pick a color again. We computed the area of this rectangle. What about the height of this length? This is f of x, right? So if you multiply f of x by dx, you will get the area of this rectangle. Adding all these areas, you will get the area under this curve from A to B. It was the idea of integral for the function of one variable. What about the idea of double integral? The idea of double integral, instead of finding the area under a curve, we find the volume under a surface. How do we get a surface? As I told you, for each input x and y, you have a value z. Combining all the z's, you have a surface, and you want to compute the volume under this surface. It is the idea of double integral. now let me explain how do we get this formula. Okay, I want to explain how do we get this formula. Now let's look at this figure. I draw a length dx here, okay, and as you see, this is xyz plane. Of course, since you have the function of two variables f of xy, for each x and y you will have a height. You will have a height. Okay, so let's say we fix y, and we, by fixing y, we create a thin plane like this. Okay, this is a thin plane, and if you want to compute the area of thin plane just using the idea of integral for function of one variable, just remember this idea. You multiply dx by, we multiplied dx by f of x for the function of one variable. Now we multiply this length dx by f of xy instead of f of x, since we have function of two variables now. Okay, if you multiply f of xy by dx, you will have the area of this blue rectangle, okay, and if you add them up, all these blue rectangles, if you have many blue rectangles, and if you sum them up, then you will find the area of this thin slice. Okay, so how do we do this? Now we have a sliver. So integral from 0 to b, if you take the integral from 0 to b, this is b and this is a. Okay, this is the integral of f of xy from 0 to b. Okay, if you obtain this integral, you will find the as a result you will find the function of x. You will find the function with respect to x. Okay, so what do we do here? We find the area of this sliver. The whole plane, by taking the integral from 0 to b f of xy dx. Now if you choose a distance here, let's say this is dy, let's call this distance as dy, and let's create a rectangle here. Okay, now I continue to draw. Let's try to create a rectangular box to have a volume. Okay, now I continue to draw. If you multiply the area of the blue plane by dy, you will get the area of the blue. This is the area of the blue plane sliver by dy. You will get the volume of that box. Okay, you will get the volume of that box. So if you integrate if you integrate, so I mean if you sum all these volumes from 0 to A, okay, you have many volumes, you have many solids, so you have many volumes to find. If you integrate from 0 to A, okay, if you integrate from 0 to A, then you will finally find the volume under this surface. It is the idea of double integral. I hope you understand the idea of double integral. Now let me continue to give the properties of double integral. The first property, actually the properties of double integral are the same as the properties of single integral for the function of single variable. The first property, you can it's possible to write double integral of f plus g as double integral of f plus double integral of g. You have the same property. If you want to multiply by a constant k, it's possible to take outside the constant. If you have a relation between two functions, if g is greater than f, then the double on a region, of course, the double integral of g is also greater than f. Now I want to remind something else. For the function of one variable, we find the integral on R, on real line. So we find the area of the curve of f of x on a real line. If you have function of two variables, then of course you have a surface and you want to find the volume under the surface. Surface mean you are not on R anymore, you are on R square. So you have two dimensions. Okay, this is the basic difference in between the function of one and two variables. What about the sixth property? It is also important. If you have two non-overlapping regions R and S, and if you want to compute the double integral of a positive function f of xy on that union, you can compute the double integrals separately on both regions. Let's look at this example. We have two non-overlapping regions R and S here. So the values of some double integrals are given in the question. For instance, the value of double integral on R and on S are given as 2 and 6. Okay, so the double integral on G on two different regions, that is on R and on S, are also given. We are requested to find this double integral. Let me quickly solve the question. So the double integral on the union 10 times f plus 20 times g, of course dA is also means, let me clear. dA means, I will introduce all these notations later, but let me write dx dy or dy dx. Okay, so it is equal to 10 times double integral of f dA plus 10 times double integral of f dA, of course on both regions R and S, plus 20 times double integral of f, no f anymore, of course, double integral of g on R plus, and double integral of g on the other region S. Okay, so we have all information in the question. Let's use them. Double integral of f on R is 2 So you have this. Double integral of f on s is 6 by question again, plus double integral of g on r is 3. Double integral of g on s is 7. Okay, if you add them all numbers, you will have this. Okay, this is 260, the answer 260. So in this video I tried to give the idea of double integral. In the next video I will solve many questions and I will give some techniques to solve double integral questions. I hope everything is clear, so I will continue to teach in the next video.